the science of gut health. What research really reveals about your second brain? Your gut contains more nerve cells than your spinal cord, produces 90% of your body's serotonin, and houses trillions of microorganisms that influence everything from your mood to your immune system. Yet most people know more about maintaining their smartphone than understanding this complex ecosystem that determines so much of their health and well-being. Dr. Emeran Mayer, director of UCLA's Center for Neuroscience, Stress, and the Gut, made a discovery that's revolutionizing medicine. The gut and brain communicate through what he calls the gut-brain axis, using the same neurotransmitters, immune signals, and hormonal pathways. This means your digestive system isn't just processing food, it's actively influencing your thoughts, emotions, and behavior in ways that scientists are only beginning to understand. The research emerging from labs around the world reveals that digestive health affects mental clarity, immune function, skin health, energy levels, and even personality traits. But here's what's truly shocking. Most of what people think they know about gut health comes from marketing claims rather than scientific evidence. And many popular gut healing approaches actually conflict with what research shows about how the digestive system really works. Today, we're going to explore the fascinating science of gut health based on peer-reviewed research from leading institutions. You'll discover how your microbiome influences systems throughout your body, why the gut is called your second brain, and what the current research actually shows about supporting digestive wellness through evidence-based approaches. But before we dive into the science, I need to be absolutely clear about the scope and limitations of this educational content. Critical medical disclaimer. This video presents educational information about gut health research and is not intended to diagnose, treat, prevent, or cure any medical condition. Digestive issues can indicate serious underlying conditions, including inflammatory bowel disease, celiac disease, SIBO, food allergies, infections, or other disorders requiring professional medical diagnosis and treatment. The information presented should never replace consultation with qualified healthcare providers, including gastroenterologists, registered dietitians, or other medical professionals. The microbiome revolution. The human gut microbiome contains approximately 100 trillion microorganisms representing over 1,000 different species, making it one of the most complex ecosystems on Earth. Dr. Rob Knight's research at UC San Diego reveals that this microbial community is so influential that some scientists consider it a separate organ system with functions as important as your heart or liver. What makes the microbiome research so revolutionary is the discovery that these microorganisms aren't just passive inhabitants of your digestive system. They actively produce neurotransmitters, regulate immune responses, influence hormone production, and even affect gene expression in ways that impact your entire body. Dr. Sarkis Mazmanian's groundbreaking research at Caltech found that gut bacteria produce over 50 different neurotransmitters, including serotonin, dopamine, and GABA. This means your gut microbes are literally manufacturing the same chemicals that psychiatric medications target, helping explain why digestive health and mental health are so interconnected. The diversity aspect of the microbiome is particularly important. Dr. Erika Sonnenberg's research at Stanford shows that microbiome diversity has declined dramatically in industrialized populations over the past century. Her studies comparing rural populations with urban populations found that people in industrialized countries have lost approximately 40% of their ancestral microbial diversity, with potential implications for immune function, metabolism, and disease resistance. Dr. Justin Sonnenberg's research reveals that this diversity loss isn't just statistical curiosity, it has functional consequences. A diverse microbiome is more resilient to disruptions, better at preventing harmful bacteria from colonizing, and more effective at producing beneficial compounds that support health throughout the body. The timing of microbiome development is also crucial. Dr. Martin Blazer's research at NYU shows that the first few years of life are critical for establishing healthy microbial communities. And disruptions during this period through factors like unnecessary antibiotic use or cesarean delivery can have lasting effects on immune development and disease risk. But here's what's particularly interesting about current microbiome research. Scientists are discovering that the microbiome is highly individualized. Dr. Pierre Bourque's research at the European Molecular Biology Laboratory found that each person's microbiome is as unique as their fingerprint, with individual variations that affect how they respond to foods, medications, and environmental factors. This individuality helps explain why generic approaches to gut health often produce inconsistent results. What supports one person's microbiome might be neutral or even counterproductive for another person, depending on their existing microbial communities, genetic factors, and health status. Dr. Aaron Elenoff's research at the Weizmann Institute demonstrates this principle through studies, showing that people can have completely opposite blood sugar responses to identical foods based on their individual microbiome composition. This personalized response pattern appears to extend beyond just blood sugar to immune responses, inflammation levels, and other health markers. The research also reveals that the microbiome is remarkably dynamic, changing in response to diet, stress, medications, travel, and other lifestyle factors within days or even hours. This plasticity is encouraging because it suggests that positive changes are possible. But it also means that maintaining microbiome health requires ongoing attention to factors that influence microbial communities. Understanding the microbiome revolution helps explain why digestive health is connected to so many other aspects of wellness, and why supporting gut health requires more sophisticated approaches than simply taking probiotics or eliminating certain foods. The gut-brain connection decoded. The relationship between your gut and brain is so extensive that neuroscientists now refer to the digestive system as the second brain, or enteric nervous system. Dr. Michael Gershen's research at Columbia University revealed that the gut contains over 500 million neurons, more than the spinal cord, and can function independently of the central nervous system. This gut-brain communication happens through multiple pathways that researchers are still mapping. The vagus nerve, which Dr. Kevin Tracy calls the inflammatory reflex, carries signals directly between the gut and brainstem, allowing rapid communication about digestive status, immune responses, and microbial activity. Dr. John Cryon's research at University College Cork demonstrates that gut bacteria can influence behavior and mood through this gut-brain axis. His studies show that certain bacterial strains can reduce anxiety-like behavior in laboratory models, while disruptions to the microbiome can increase stress responses and depressive symptoms. The neurotransmitter production in the gut is particularly fascinating. Dr. Mark Light's research on microbial endocrinology shows that gut bacteria don't just produce neurotransmitters, they respond to them. This creates a complex communication network where your thoughts and emotions can influence your gut bacteria, which in turn affects your mental state. Dr. Premisal Bursik's research at McMaster University found that gut bacteria can influence personality traits. His studies show that anxious mice receiving gut bacteria from calm mice become more exploratory and bold, while calm mice receiving bacteria from anxious mice become more cautious and stress-reactive. While human studies are more limited, similar patterns appear to exist in people. The immune connection is equally important. Dr. Sven Peterson's research shows that approximately 70% of the immune system is located in or around the digestive tract, where it constantly monitors microbial communities and food particles. This gut-associated lymphoid tissue communicates directly with the brain through immune signaling molecules called cytokines. Dr. Christopher Lowry's research at University of Colorado demonstrates that certain gut bacteria can influence the stress response system. His studies show that specific bacterial strains can reduce inflammatory responses to stress and improve resilience to anxiety-provoking situations. The blood-brain barrier, long thought to be impermeable, is now known to be influenced by gut health. Dr. Maiken Nedergaard's research shows that inflammation originating in the gut can affect brain barrier function, potentially allowing inflammatory molecules to reach brain tissue and influence mood, cognition, and behavior. Sleep quality is another area where gut-brain communication plays a crucial role. Dr. Robert Stickgold's research at Harvard shows that gut bacteria influence circadian rhythms through the production of metabolites that affect sleep-wake cycles. This helps explain why digestive issues often coincide with sleep disturbances. The stress response system is particularly sensitive to gut-brain signaling. Dr. Yvette Taches's research at UCLA demonstrates that stress hormones like cortisol directly affect gut bacteria composition, while gut bacteria produce compounds that influence stress hormone production, creating feedback loops that can either support or undermine stress resilience. Understanding the gut-brain connection reveals why digestive health affects so many aspects of mental and emotional well-being, and why supporting gut health often leads to improvements in mood, cognitive function, and stress management that extend far beyond just digestive symptoms. The immune system headquarters. Your digestive system serves as the headquarters for approximately 70% of your immune system, making gut health one of the most important factors in overall immune function. Dr. Yasmin Belkade's research at the National Institute of Health shows that the gut immune system faces an extraordinary challenge, distinguishing between beneficial microbes and food particles that should be tolerated versus harmful pathogens that need to be eliminated. This immune surveillance happens through specialized cells called PRS patches and other gut-associated lymphoid tissue that samples everything passing through the digestive system. Dr. Hiroshi Kiyono's research demonstrates that these immune cells communicate with the rest of the body through lymphatic and circulatory systems, meaning that immune decisions made in the gut influence immune responses throughout the body. The concept of immune tolerance is particularly important for understanding gut health. Dr. Catherine Nagler's research at University of Chicago shows that exposure to diverse microbes and food antigens during early life helps. Cues train the immune system to respond appropriately to different threats. When this tolerance development is disrupted, it can lead to allergies, autoimmune conditions, and chronic inflammation. Dr. Kenya Honda's research reveals that certain gut bacteria actively promote immune tolerance by stimulating regulatory T cells, which help prevent excessive immune responses to harmless substances. This bacterial immune cooperation helps explain why antibiotic use, which disrupts beneficial bacteria, can sometimes lead to increased allergies and autoimmune problems. The inflammatory response system is closely tied to gut health through what researchers call the leaky gut inflammation axis. Dr. Alessio Fasano's research at Harvard shows that intestinal permeability, often called leaky gut, can allow bacterial components and food particles to cross the intestinal barrier and trigger immune responses. However, it's important to understand that some degree of intestinal permeability is normal and necessary for proper immune function. Dr. Gerald Turner's research at University of Chicago demonstrates that the intestinal barrier is designed to be selectively permeable, allowing beneficial nutrients to pass while blocking harmful substances. Problems arise when this selective permeability becomes dysregulated. Dr. Ramnik Xavier's research at Massachusetts General Hospital shows that inflammatory bowel diseases involve complex interactions between genetics, immune function, and microbial communities. This research reveals that gut health problems often result from multiple factors rather than single causes, which is why simple interventions don't always produce dramatic results. The connection between gut health and autoimmune conditions is an active area of research. Dr. Jose Scher's studies show correlations between certain gut bacterial patterns and conditions, like rheumatoid arthritis, though causation versus correlation remains under investigation in many cases. Food sensitivities and allergies also involve gut immune function in complex ways. Dr. Scott Sickerer's research shows that food allergies involve multiple factors, including genetics, early life exposures, and gut microbiome composition. This complexity helps explain why elimination diets sometimes provide relief but don't address underlying immune dysfunction. The aging process affects gut immune function significantly. Dr. Claudio Franceschi's research on immunosenescence shows that age-related changes in the microbiome and gut barrier function contribute to increased inflammation and reduced immune responses in older adults. Understanding the gut as immune system headquarters helps explain why digestive health influences susceptibility to infections, autoimmune conditions, and inflammatory diseases throughout the body. It also reveals why supporting gut health requires attention to factors that influence immune balance rather than just focusing on digestive symptoms. The research on dietary factors. When it comes to supporting gut health through diet, the research reveals both promising findings and important limitations that conflict with many popular claims. Dr. Justin Sonnenberg's research at Stanford shows that dietary fiber is one of the most important factors for maintaining beneficial gut bacteria. But the relationship is more complex than simply eating more. Fiber. Different types of fiber support different bacterial communities in ways that scientists are still mapping. Dr. Heidi Staudzer's research demonstrates that fermentable fibers like those found in legumes, vegetables, and whole grains serve as fuel for beneficial bacteria, producing short-chain fatty acids that support gut barrier function and reduce inflammation. However, Dr. Peter Gibson's research on FODMAPs reveals that some high-fiber foods can worsen symptoms in people with certain digestive conditions like irritable bowel syndrome. This research shows that the same foods that support gut health in some people can cause problems in others, highlighting the importance of individualized approaches. The fermented foods research is particularly interesting. Dr. Maria Marco's studies at UC Davis show that foods like yogurt, kefir, and sauerkraut can introduce beneficial bacteria to the digestive system. But whether these bacteria establish permanent residence depends on individual factors, including existing microbiome composition and immune status. Dr. Christopher Gardner's research at Stanford found that people consuming fermented foods for 10 weeks showed increased microbiome diversity and reduced inflammatory markers compared to those eating high-fiber diets. However, he notes that both approaches showed benefits, and individual responses varied significantly. The polyphenol research adds another layer of complexity. Dr. Francisco Tomás Barberón's studies show that plant compounds found in foods like berries, green tea, and dark chocolate can promote beneficial bacterial growth. But these compounds require specific bacteria to be metabolized effectively, meaning that people with different microbiome compositions may experience different benefits. Timing of eating also influences gut health in ways that researchers are beginning to understand. Dr. Sachidananda Panda's research on circadian rhythms shows that gut bacteria follow daily cycles that can be disrupted by irregular eating patterns, potentially affecting both digestive and metabolic health. The elimination diet research reveals both benefits and risks. Dr. Daly's studies show that removing potential trigger foods can provide symptom relief for some people with digestive issues. However, Dr. Kevin Whelan's research demonstrates that overly restrictive diets can reduce beneficial bacteria and potentially worsen long-term gut health if maintained unnecessarily. Processed food research consistently shows negative associations with gut health. Dr. Andrew Gewertz's studies demonstrate that certain food additives can alter gut bacteria composition and increase intestinal inflammation. However, the research also shows that the effects depend on individual factors and that not all processed foods have identical impacts. The protein source research reveals interesting patterns. Dr. Lee's studies show that plant-based proteins tend to promote different bacterial communities than animal proteins. But both can be part of healthy dietary patterns depending on individual needs and overall diet quality. Alcohol's effects on gut health are well documented but dose-dependent. Dr. Bernd Schnabel's research shows that excessive alcohol consumption disrupts gut barrier function and promotes harmful bacterial growth, while moderate consumption may have neutral or even slightly positive effects in some contexts. Understanding the dietary research helps explain why there is no single gut-healing diet that works for everyone, and why supporting digestive health often requires personalized approaches based on individual symptoms, conditions, and responses to different foods. The lifestyle factors that matter beyond diet. Research reveals that numerous lifestyle factors significantly influence gut health in ways that are often overlooked in popular discussions about digestive wellness. Dr. Christopher Karp's research shows that stress management may be one of the most important factors for maintaining healthy gut function, yet it's rarely addressed in gut health protocols. Chronic stress affects the gut through multiple pathways. Dr. Yvette Tach's research at UCLA demonstrates that stress hormones like cortisol directly alter gut bacteria composition, reduce beneficial bacterial diversity, and impair gut barrier function. This creates a cycle where stress worsens gut health and poor gut health increases stress sensitivity. The sleep research is equally compelling. Dr. Martha Hotz's Vitaterna studies showed that disrupted sleep patterns alter gut bacteria composition and affect the production of hormones that regulate digestion. Poor sleep quality can reduce beneficial bacteria and increase inflammatory bacteria within just a few days. Exercise has complex effects on gut health that depend on intensity and individual fitness levels. Dr. Jeffrey Woods' research shows that moderate exercise increases beneficial bacteria diversity and reduces inflammatory markers. However, extreme exercise can temporarily disrupt gut barrier function and alter bacteria composition, though these effects typically resolve with recovery. Social connections influence gut health through the gut-brain axis. Dr. Steve Cole's research on social isolation shows that loneliness triggers inflammatory pathways that can affect gut bacteria composition and immune function. This helps explain why social support often improves not just mental health, but physical symptoms as well. Environmental exposures play crucial roles that are often underestimated. Dr. Martin Blazer's research shows that antibiotic use, even when medically necessary, can have lasting effects on gut bacteria diversity. His studies suggest that each course of antibiotics can permanently eliminate certain bacterial strains, with cumulative effects over lifetime antibiotic exposures. The hygiene hypothesis research reveals that some exposure to microbes may actually support gut health. Dr. Graham Rook's studies on old friends hypothesis suggests that reduced exposure to diverse microorganisms in modern environments may contribute to immune dysfunction and reduced gut bacteria diversity. Travel affects gut health in predictable ways. Dr. Emeran's research shows that international travel typically increases gut bacteria diversity temporarily as people are exposed to new microbes and foods. However, travelers' diarrhea and other digestive issues demonstrate that rapid microbial changes can also cause problems. Age-related changes in gut health are inevitable, but can be influenced by lifestyle factors. Dr. Marcus Klessen's research shows that gut bacteria diversity typically declines with aging, but older adults who remain physically active and maintain varied diets show less dramatic changes than sedentary peers. Medication effects extend beyond antibiotics. Dr. Martin Kortmann's research shows that proton pump inhibitors, commonly used for acid reflux, can significantly alter gut bacteria composition by changing stomach acidity. Many other medications, including NSAIDs, antidepressants, and diabetes medications, also influence gut health in ways that are still being studied. The timing of various lifestyle factors matters more than many people realize. Dr. Ruthlay's research shows that gut bacteria follow circadian rhythms, with different bacterial activities peaking at different times of day. This suggests that the timing of meals, exercise, and even medication administration could influence their effects on gut health. Understanding lifestyle factors helps explain why gut health approaches that focus only on diet or supplements often provide limited benefits, and why comprehensive approaches addressing stress, sleep, exercise, and environmental factors tend to be more effective for supporting long-term digestive wellness. What the research really shows. After decades of microbiome research, several key principles have emerged that conflict with many popular claims about gut health. The first important finding is that gut health is highly individual, and there is no single optimal microbiome composition that applies to everyone. Dr. Curtis Huttenhoer's research at Harvard shows that healthy people can have dramatically different gut bacteria compositions while maintaining similar digestive function. This means that trying to achieve a specific bacterial profile may be less important than supporting overall microbial diversity and function. The speed of change is another area where research contradicts popular claims. While some gut bacteria changes can happen within days, Dr. Lawrence David's research at Duke University shows that stable, lasting changes to the microbiome typically require weeks to months of consistent interventions. Claims about healing your gut in 7 days generally aren't supported by scientific evidence. Supplement research reveals mixed results that depend heavily on individual factors. Dr. Gregor Reed's research shows that probiotic supplements can be beneficial for some people with specific conditions, but they don't automatically improve gut health in healthy individuals. The effects depend on the specific strains used, the dosage, individual microbiome composition, and whether the bacteria can successfully colonize the gut. The elimination diet research shows both benefits and limitations. Dr. Peter Gibson's work demonstrates that removing potential trigger foods can reduce symptoms in people with conditions like IBS. But these restrictive approaches may not address underlying causes and can sometimes reduce beneficial bacteria if maintained long-term without professional guidance. Testing and monitoring presents significant challenges. While gut microbiome testing is widely available, Dr. Rob Knight notes that interpreting these results for individual health recommendations remains scientifically challenging. The research hasn't yet established clear relationships between specific bacterial patterns and optimal interventions for most healthy individuals. The placebo effect in gut health is substantial. Dr. Kirsten Tillish's research shows that people often experience significant improvements in digestive symptoms from interventions that have no specific biological effects, highlighting the importance of controlled studies and the powerful influence of expectations on gut-brain communication. Timing and context matter more than most people realize. Dr. Aaron Elinoff's research shows that the same foods or interventions can have different effects on the same person depending on factors like time of day, recent meals, stress levels, and sleep quality. This variable response helps explain why rigid protocols often produce inconsistent results. The research also reveals that many gut health problems are symptoms of other issues rather than primary problems themselves. Dr. Mark Mento's research on SIBO shows that small intestinal bacterial overgrowth is often secondary to motility problems, food poisoning episodes, or other underlying conditions that need to be addressed for lasting improvement. Inflammation is both a cause and consequence of gut health problems in ways that create complex feedback loops. Dr. Emily Biennois' research shows that chronic low-grade inflammation can disrupt gut bacteria balance, while bacterial imbalances can promote inflammation, making it difficult to determine which problem to address first. The mental health connections, while real, are often more complex than popular media suggests. Dr. John Cryan's research shows that while gut-brain communication influences mood and behavior, mental health conditions typically involve multiple factors beyond just gut health, and addressing gut issues alone rarely resolves complex psychological problems. Perhaps most importantly, the research shows that sustainable gut health improvements typically require addressing multiple factors simultaneously rather than focusing on single interventions. This system's approach aligns with how the gut actually functions as part of interconnected physiological networks rather than as an isolated system. Moving forward with science-based approaches. The current state of gut health research provides a foundation for evidence-based approaches while highlighting areas where more research is needed. The key insight from decades of microbiome studies is that supporting gut health requires personalized, multifaceted approaches rather than universal protocols. If you're interested in supporting your digestive health, the research suggests starting with factors that consistently show benefits across diverse populations. Consuming a varied diet rich in different types of fiber from whole foods. Managing stress through evidence-based techniques like regular exercise and adequate sleep. Limiting unnecessary medication use while working with healthcare providers when medications are needed, and avoiding extremes in diet or lifestyle that might disrupt gut balance. The most important step is consulting with qualified healthcare providers who can evaluate your individual situation. Rule out underlying conditions that might require medical treatment, and provide personalized recommendations based on your specific symptoms, health history, and goals. Gastroenterologists, registered dietitians, and other specialists have training that allows them to distinguish between minor digestive issues and more serious conditions that require professional treatment. For ongoing education, focus on information from reputable sources, including peer-reviewed research, professional medical organizations, and institutions with expertise in gastroenterology and microbiome research. Be cautious of claims that seem too good to be true, promise rapid results, or suggest that complex health issues can be resolved through simple interventions. Remember that gut health is connected to overall health in ways that researchers are still discovering. Supporting your digestive system through evidence-based lifestyle approaches often improves not just digestive symptoms, but energy levels, mood, immune function, and overall well-being. The goal isn't achieving perfect gut health, but rather supporting the complex systems that contribute to your overall wellness. The future of gut health research holds promise for more personalized approaches based on individual microbiome profiles, genetic factors, and health status. Until these advanced approaches become widely available, the current evidence supports balanced, moderate approaches that address multiple aspects of health simultaneously rather than focusing exclusively on digestive factors. Your gut health journey should be guided by scientific evidence, professional medical advice, and careful attention to how your individual body responds to different approaches. The research has provided us with valuable insights into this complex system, but applying that knowledge effectively requires wisdom, patience, and often professional guidance tailored to your unique circumstances.